All right, there's a lot going on here in this proof. So let's start with what we know. If we have any two eigenvalues that are not equal to each other, then this means that their corresponding eigenvectors are not going to be, sorry, let me move this down. Not only are they not going to be equal to each other, they're not going to be multiples of each other because they'll be linearly independent. I can only get one eigenvector from one eigenvalue. So if these two are going to be independent from each other, that means that P inverse exists, which of course means that P times P inverse, or P inverse P, let's put them that way, is going to be equal to the identity matrix. So P inverse of, we've got our matrix made of x1, x2. So that's going to be equal to 1, 0, 0, 1. This implies that P inverse of x1 P inverse x2 is going to be 1, 0, 0, 1. So my P inverse x1 is going to be 1, 0. P inverse x2 is going to be 0, 1. Now let's come up here to this part. We have P inverse AP. Well, we know that AX1 is going to be our lambda 1 x1. So let's write that down, that AX1 is lambda 1 x1, and AX2 is lambda 2 x2. Okay, that's because we know we have eigenvalues and eigenvectors for matrix A. So now coming into here, we've got some P inverse of A, and then P we've defined to be x1 augmented with x2. Well, that's going to give us P inverse of A x1 augmented with A x2. That's going to give us lambda 1 x1 with lambda 2 x2. But since lambda is just a constant, then I can turn this into lambda 1 P inverse x1 augmented with lambda 2 P inverse x2. As we saw over here, P inverse x1 is 1, 0. So when I multiply by lambda 1, I will get lambda 1, 0. P inverse x2, sorry, I lost my P inverse. It's not a vector, it's a matrix. All right, so that's going to give me 0, lambda 2, because this is going to be 0, 1. Okay, so this is the theorem of turning matrices into diagonal matrices. So if I have a matrix A that has two unique eigenvalues, then I can write down matrix P with those eigenvalues, find P inverse, and the result is going to be a diagonal matrix, so values only on the diagonal, and the rest of the values are 0. If you want to see this written up articulately, you can go look at the notes. We've got it down here. So a 2 by 2 matrix A with distinct eigenvalues and corresponding eigenvectors is diagonalizable. Matrix P diagonalizes A, and here is my result of P inverse AP.